When finding the domain, I always like to graph it first. So what I would do is do 1 divided by, put parentheses around the bottom, and take a look at what the graph is showing you. The graph is showing you something like this. So it goes down like this, and then it comes down like this. So it's looking like uses all the x values, but it has a break. Well, here's the domain. The domain is all real numbers, but this bottom piece cannot equal 0. So what number is going to make that 0? So I'm going to add 4 to the other side. So I have 2x. I'm going to divide both sides by 2. So x cannot be 2. So the domain is all real numbers but 2. So if I'm going to write it in interval notation, I go from negative infinity to 2. It can't include 2, but it starts again right after and goes to infinity. So it's all real numbers, but what the denominator can equal. All right, the next problem looks something like this. If I put it in my calculator, it goes like this. So the domain is the furthest to the left and everything that happens over here. So in this case, it looks like the domain is greater than -4. But here's how we prove this. Square roots have to be greater than 0 when I solve it. I could put the number 0 in here, and I would get 4, and the square root of 4 is 2. I could put the number -1 in here, and -1 plus 4 is 3, and the square root of 3 is an approximation. So when I have a square root, I take x plus 4, what's inside, and it has to be greater than or equal to 0. When I solve, this is what I get. There's my domain. Any number that I plug in that's greater than -4 will fit into this equation. So it can be -4 and goes every way to the right, so it goes to infinity, and there's my domain. Write this problem in standard form. Standard form has to go x plus or minus a y equals a number. No fractions. And the x has to be positive. So the first thing I like to do is clear my fractions. So I'm going to multiply everything by 3. Those will cancel. So I have 3y equals x plus 27. Next step, I'm going to subtract x to both sides. So I have -x plus 3y equals 27. Well, like I said just a second ago, x can't be negative, so I'm going to divide or multiply everything by a -1, or change the sign of everything. So x minus 3y equals -27 is my answer in standard form. Write an equation in standard form that passes through the point 2, 4 and is parallel to that equation. So the first thing I want to know, 1, 2, 1, 2, 3, 4, it's going to pass through that point but be parallel to this equation. So being parallel means same slope. So the first thing I have to do is find the slope of this equation. So I have 2y equals, if I move the x to the other side, I have -3x plus 4. Divide everything by 2, and y equals -3/2 x plus 2. Well, here's the important piece right here, is the -3/2. So point slope formula. Y equals mx minus x1 plus y1. So this is the version of the point slope formula. What do I know? Same slope. The opposite of x, so -2 because this is my x value, and there's my y value. So the first thing I have to do is write an equation. So y equals -3/2 x plus 3 plus 4. So I get y equals -3/2 x plus 7. So this is an equation that's going to run parallel to that one right there. But it wants it in standard form. So the first thing I'm going to do is get rid of my fraction by multiply everything by 2. So I have 2y equals 3x plus 14. Then the next step is the 3 has to go over there, so minus 3x plus 2y equals 14. And the last step is going to be divide everything by a -1, so I have 3x plus 2y, minus 2y equals -14. Alright, next problem is just some evaluating. So the first problem, I have a function up here. All I'm going to do is plug in for x. When I plug in for x, I use parentheses. So negative x, instead of x, I'm going to use -1 squared plus 5. This piece here, negative times a negative, is a positive. Bring everything else down. So I brought this negative piece down, and my answer is 4. If I plug in a 3, using parentheses, I get 9, bring everything else down, and I get -4. So this problem is really a lead into the next problem. So a problem like this looks very busy. All we're going to do is figure out which domain these numbers fall in and only evaluate in that domain. So if I'm evaluating if x is less than -1, my answer is 4. If x is in between -1 and 1, I plug it in right here. If x is greater than 1, I plug it in right here. So -2, does -2 fall in this domain, or this domain? -2 falls in the top domain, so my answer is just 4. F of 1, is it less than -1? No. Is it in between or equal to -1 and 1? And the answer is yes. So all I'm going to do is I'm going to plug it in. Instead of x, I put parentheses, and in that parentheses I put 1. So when I simplify, my answer is 1. One other example, f of 5. Well, it's not less than -1. It's not between 1 and 1. It falls in this domain, which means I simplify as 5 plus 1, which is 6. Last problem, we want to find f of g of x. The first thing I do is I rewrite it like this, f of g of x. And we always start in the middle and replace. Well, I know g of x is x over 2. Now I'm going to plug it into f. So I'm going to rewrite f, and everywhere I see an x, I'm going to put a parentheses. So all I did was rewrite this, and in for that x, I put an open parentheses. Then in that parentheses, I'm going to put this piece right here and simplify. The 2's cancel, and my final answer is x plus 1. Let's go the opposite direction. G of f of x. So I'm looking for g of f of x. I'm going to start in the middle, so I get 2x plus 1. Then I'm going to rewrite g, x over 2, and I get 2x plus 1. This is my final answer, or you can split them up, and that would give you x plus 1/2. I would accept either answer.